In this lesson, we're going to look at a key theorem in geometry called the exterior angle theorem. This theorem regards the angles of a triangle. We're going to first look at the text of the theorem that's in the yellow box. We're going to prove the theorem, and then we're going to do an example that uses that theorem. So first, what is the exterior angle theorem? For the exterior angle theorem, we look at a triangle with three interior angles, here labeled as 1, 2, and 3, and also an exterior angle, which is an angle formed by an extension of one of the sides of the triangle and one of the other sides of the triangle itself. So the theorem says, given a triangle with interior angles 1, 2, and 3, along with exterior angle 4 that shares a vertex with angle 3, vertex is just that point where those sides meet. Angle 3, angle 4 share that vertex, so we can say that 4 is an exterior angle that shares a vertex with angle 3. When that's all the case, we have that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. In other words, if this is x and this is y, then angle 4 is going to be x plus y. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. Let's identify why this is the case. In order to be able to prove this, we need to recall that inside a triangle, we always have a sum of 180 degrees for our angles. So in a triangle like this, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. That's a fact that's always true for any triangle, and that's going to form the basis of our proof of this theorem. Now, one other thing to notice is not only are those three angles together adding up to 180, but also angle 3 and angle 4 also add up to 180 degrees because they share a vertex and they lie on a line. So we can also write that the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. Okay, great. Now, let's take a look at what happens when we subtract these two equations from each other. I'm going to do the measure of angle 1, the measure of angle 2, and the measure of angle 3 subtracted by the measure of angle 3 and subtracted by the measure of angle 4. Let me maybe just write that out so it's a little bit clearer. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. And what are we subtracting from it? We're subtracting the measure of angle 3, and we're also subtracting the measure of angle 4. These two cancel out. On the right-hand side, we have 180 degrees and 180 degrees. When we subtract those, we end up with 0. So right now we have measure of angle 1 plus measure of angle 2 minus measure of angle 4 equals 0. From this point, we can just add the measure of angle 4 to both sides, and then we get measure of angle 1 plus measure of angle 2 is equal to the measure of angle 4. That's exactly the statement that the exterior angle theorem gave us, and so that proves for us that the exterior angle theorem is true. It just follows from the fact that the sum of all three angles inside the triangle is 180 degrees, but also that exterior angle is going to add up to 180 degrees when added to the interior angle that it's adjacent to. That is, the measure of angle 4 plus the measure of angle 3 is also going to be 180 degrees. So now let's use this fact that we've justified the exterior angle theorem to answer a question. In this example, it says determine the measure of angle ABC given the relationship shown in the diagram. In this diagram, we can see that angle A over here is labeled as x, angle B is labeled as 3 over 2x, and angle C over here is labeled as x plus 81 degrees. We know from the exterior angle theorem that angle A and angle B should add up to this exterior angle located at vertex C. Let's write that now as an equation. Angle A, the measure of angle A, which is x, plus the measure of angle B, which is 3/2 x, is equal to that exterior angle at C, which is x plus 81 degrees. Now we can solve this equation in order to obtain x. The very first thing that we can do is we can subtract x from both sides, which is going to get rid of x entirely. So right now we're left with 3/2 x is equal to 81 degrees. From this point, we can multiply both sides by 2/3. The reason that we'll want to multiply both sides by 2/3 is because it's going to get rid of the 3 halves, because the 3's will cancel here and the 2's will cancel here, canceling from a numerator and a denominator. So right now, in order to figure out x, we need to take 81 degrees and multiply that by 2/3. In order to multiply a number by a fraction, turning that whole number into a fraction over a denominator of 1 can be helpful. So 81 over 1 times 2/3. Let's do some cancellation before we actually do some multiplication, just to keep the numbers as small as possible. Right now, I'm noticing that 81 and 3 have a common factor. Specifically, 81 divided by 3 gives us 27. And of course, 3 divided by 3 is equal to 1. So we can divide the 81 and the 3 both by 3 to give us 27 and 1. So at this point, we can now multiply the numerators and multiply the denominators. 27 times 2 is 54. In the denominator, we just have 1 times 1. That's 1. So we have 54 over 1, but over 1 isn't really needed to be written. It's just 54 degrees. That's the value of x, which then tells us the measures of the other angles. Specifically, that 54 degrees can be labeled here for angle A as 54. We can also compute 3/2 x, but you may remember that 3/2 x, we actually saw before that 3/2 x is equal to 81 degrees. So we can just put that in the diagram. And then also we have x plus 81. X plus 81 is going to be 54 degrees plus 81 degrees. That's 135 degrees. So we've labeled all of the angles that we have here. We now need to determine the measure of angle ACB. The measure of angle ACB is asking us to find the measure of this angle here. I'm going to call this y. We know that that angle y and the exterior angle at C, those ones add up to 180 because they form a straight line. So we can then write y plus 135 degrees is equal to 180 degrees. If we subtract 135 from both sides, we get y equals 180 degrees minus 135 degrees, or y is 45 degrees. And that's the answer to our question. So we just use the exterior angle theorem in order to find a missing angle, given some partial information about the triangle. And in fact, along the way, we were able to find all of the angles in the diagram. Thanks for watching.